Yo, algebrainiacs! Welcome to the Johnson Kendro video hour!
But it's not an hour.
But I do like our little logo there. That's very cool. Alright, and it doesn't mean just kidding. Alright, we're going to talk about normal distribution. Because we are normal math teachers.
Not really.
Alright, that's all good. Alright, normal distributions occur often in real life. They really, really do. For example, you guys take standardized tests all the time. If you're talking about heights of adults or even little tiny babies, all of that has to be, it goes along with normal distribution. All right, the graph is called the normal curve. All right, they have certain characteristics. The graph has a maximum at the center, and the graph is symmetrical about the mean, meaning it's equal on both sides, and then there's a mean, median, mode, and they're all equal.
I always find that interesting. The mean, the median, and the mode are the same.
Yeah.
All right, so this is an example of the normal curve. And there's lots of details there, so you might want to hit pause and get that copy. They did a nice job color coding that for you. You need to memorize these percentages, the ones that I'm circling. The ones that are underneath the curve, you can technically figure those out as long as you have these three percentages memorized. So if you need to copy that down, go ahead and do that. I'm going to go through and explain it. So in the curve, in the center, you'll see the mean. That's very obvious right there in the middle. And the first number I circled in the red, 68% of the data fall within one standard deviation. Well, remember, it has to be symmetrical. So half of 68 is
34.
That's to the positive end of the side of the mean and to the negative side. So within one standard deviation, 68% of the data, half of it is to the right, half of it to the left.
This looks a lot like what my professors used to do in college when we get tests.
Yeah. Did you get grades according to the normal curve?
Yep.
Oh, that
And
can be stressful.
Yeah, some was good, some was not good, because you could get an A but land in the second deviation and get a B.
Yeah.
A, what you're normally used to, but a B on the curve.
Yeah. So my blue arrows there show you within two standard deviations in each direction, but again, 95% of the data is within two standard deviations, but remember we already took care of 68% of it in the red stuff that I have.
The leftover is the 27.
27, you divide 27 by 2, and that's where these two things come from.
Got it.
And then the third standard deviation, there's just a little bit more, and that makes sense with the shape of the curve. There is 99.7% total. So how many more percent is that? That's 4.7, and then half of it is to the right, and half of it is to the left. So that's how we come up with those little pieces. It is important to note that there is some data that is missing. How much?
Oh, just 0.3.
Yep, and that means that 0.15% of the data happens outside of three standard deviations on each side.
So that for a testing situation, that could be the really, really smarty pants, and then the kids who just don't put anything but their name on the test.
It is possible to have some skewed data, so these are some examples of skewed curves. Obviously, our normal distribution in the center is very symmetrical. That is not skewed. However, the two that I have on the outsides here positively skewed. This to me is kind of backwards from what you might think.
Yeah.
Because when I look at this, it looks normally distributed. But the problem is there must be some data point that is much higher than the others. Maybe perhaps an outlier somewhere up here, which skews the data in the positive direction. So even though the little lump is to the left or to the low end, it is positively skewed. And the opposite is true here. When there is a much smaller value compared to the rest of the data, the graph becomes negatively skewed.
Well, excuse me.
All right, here's how we're going to apply this. The part one lesson is really just some basics using percentages and stuff like that. We don't have to do much of the application of the curve quite yet.
Okay.
All right, so if you guys are taking notes on this, you might want to at least get a sketch with the bars. You probably don't have to have the scale and everything like that, but at least have some of the information. This is all about female brown bears, and it says that the weights of the population of female brown bears is normally distributed. And we have an experiment or a sample, and that data is contained in this histogram, and those are the orange bars. So there's little ranges of the weights, and they counted what percent of the female brown bears fit into each category. Question says approximately what percent of female brown bears weigh between 100 and 129 kilograms. So 100 is here on our little range, and 129 is here. We are going to use the scale that they gave us to estimate the totals in each bar, and then add them all up to get the appropriate percentages.
Got it.
All right, so what do you think about this bar? It's clearly, this would be 25, so it's less than 25.
23-ish.
Yeah, I think that's about 23. What do you think about the middle bar?
About 42.
42. And that looks symmetrical to me.
43 again.
Now, I will say on these estimated histograms, they're not always symmetrical.
Okay.
They will be close, but not always exactly the same. So if we want to know what percent, all we're going to do is add up those intervals here. So if we add 23% and 42% and 23%, what do we get?
88.
So 88% of female brown bears weigh between 100 and 129 kilograms.
So that's a pretty normal weight. That's why it's a normal distribution.
Oh, that makes sense. Referring to the same graph, approximately what percent of female brown bears weigh less than 120 kilograms? So here's 120, and we're talking about all of these bears. So let's finish estimating the bars. So what do you think this looks like?
That one looks like 5.
Yeah, it looks like right on the line. Now, I want you to notice there is a little bar here.
So 1.
Well, check this out. If we know that this bar is 5 and this bar is 5, and we already know there's 88 in the middle,
That's 98.
98, I got a little data here and a little data there. I think you're right. That's 1 and 1.
So 99, 100.
So use our subtraction skills there to come up with that.
Go back to 4th grade.
Yeah. So if we're finding the percent, so everything lower than 120, what numbers am I going to add together?
23, 42,
23 again, right?
5 and 1.
And 5 and 1. And when we add those together, what's that? I think that's 71.
Okay, hang on. Let's back up here a
I
little
got
bit.
too much.
Yeah,
stuff going on
120. I think we marked 130.
Yeah, I put my blue mark in the wrong thing here.
All right, so 120.
Sorry about that. Okay,
Then we
so
can take off that other figure.
I'm adding 42, 23, 5, and 1. 42, 23, 5, and 1. Sorry about that.
All righty.
So that should be the 71.
Good.
She was looking at me funny, and I knew something wasn't right.
Like, oh no, it doesn't add up.
Yeah. All right, so this is another way that things might be worded. So it says the standard deviation in weights of female brown bears is about 10 kilograms. Approximately what percent of female brown bears have the weights within 1.5 standard deviations? I am going to scroll back up briefly so that you can see. We were told the mean. The mean for brown bears is 115, so remember that's supposed to be smack dab in the middle of our curve. So 115, 1.5 standard deviations in each direction is what we want to find. And then we'll use those estimated percentages from the bars to come up with that. So 1 standard deviation, they told us, is 10 kilograms. So how could we find 1.5 standard deviations? Yeah,
Or just multiply by 10.
Okay, so 1.5 times the standard deviation is
15.
15. So that's 15 on either side. So if we add 15 to 115, what do we get?
130.
Okay, that's the high end of 1.5 standard deviations. And then we'd also have to subtract 15.
It's 100.
So that's 100. So we're looking at data of the female brown bears between 100 and 130. And I'm going to make sure I mark it right this time. Here's 100. Here's 130. We're talking about all of these guys, or gals, I guess they are. We actually already calculated that, I think. That was our 88 from the
Yeah.
beginning, wasn't it?
Yep.
But just be aware that those might be worded a little bit differently with standard deviations instead of just a numerical range.
Okay.
All right. Wow, we got lots of.
Ooh, what is that?
It's a female European eel.
Ew. Yeah. Yeah.
For a population of female European eels, the mean body length, excuse me, is 21.1 inches. Standard deviation is 4.7. Sketch a normal curve showing eel lengths at 1, 2, and 3 standard deviations from the mean. All right, so some steps if you need them. We need to always know the mean and the standard deviation, which we were given both
We
of
already
those.
do,
Yeah.
so that's nice.
That is really nice. So we're going to draw lines at the mean, plus and minus intervals, mean and plus and minus intervals of the standard deviation on a number line. And then we're going to sketch a curve, and this is very much a sketch. In fact, all of these questions on your assignment are going to look exactly the same with just different labels on the number line.
All right, so we don't need to worry how high.
Yeah. Try to make a symmetrical curve. In fact, I'm going to do my curve first.
Nice.
Not
Not
bad.
bad at all.
All right, so what was the mean for these eels?
21.1.
21.1. And then if we go one standard deviation in each direction, remember that interval is always going to stay the same. So this is one standard deviation away. What was it again?
4.7.
Okay, so we need to add 4.7 and subtract 4.7.
All right, subtract first, we'll get 16.3. Add, we get 25.8.
So that is going to stay the same throughout the entire thing, the 4.7. So now if we're 2 standard deviations away, we're going to add another 4.7 and subtract another 4.7.
All right, so from 16, it's 11.6. And going up is 30.5. And one more.
I'm color coding, so I'm going to go one more
All
here.
right. Left is 6.9. And right is 35.2.
Okay, so this is our practice for part 1, is just getting things labeled. And then as we go on into part 2, what we'll do is start applying those memorized percentages to make some predictions and probability about the data. So I'm just marking 2 standard deviations, and this whole thing is 3 standard deviations.
All right, looks great.
Oh,
It's not so bad.
no, not so bad for a 2-parter.
Okay, ta-ta for now.